A zombie apocalypse is an inevitable eventuality if humanity manages to survive long enough for evolution to take its course. In the popular game The Last of Us, the world is devastated by a fungal infection that attacks humans, turning them into pseudo-zombies driven solely to propagate the infection. Surprisingly, this scenario is more science than fiction, and an actual fungus could potentially infect humans, with Gwyneth Paltrow inadvertently playing a role in the end of the world. Known as Ophiocordyceps unilateralis or cordyceps, this particular fungus differs from its fungal counterparts. Rather than merely decomposing dead organisms like typical fungi, cordyceps has evolved to expedite the process by swiftly killing its hosts. It primarily targets ants and spiders, attaching itself to them and gradually draining their vital fluids and nutrients. The truly terrifying aspect is the fungus's intelligence. Ants, the preferred hosts, have developed a rather meticulous approach to handling their deceased. They deposit dead ants in specific chambers within their nests where waste is collected. These chambers also contain other fungi and bacteria that combat potential threats to the ant colony. In a sense, ants have developed a sanitation system and preventative medicine. Some ant colonies can even identify infected individuals and remove them far from the colony to prevent further contagion. However, cordyceps has outsmarted the ants. It has realized that simply leaving the host to die wherever it falls would limit its ability to infect many ants. Consequently, the fungus takes control of the host's mind, compelling it to perch in high locations near other ants. The infected ant clings to tree trunks or tall plants and waits. Moreover, the fungus guides the host to seek a humid environment, optimizing the chances of its own growth. Once the ant is depleted of nutrients, the fungus blooms, bursting out of the host's body and releasing infectious spores that rain down on unsuspecting insects below. Although scientists initially believed that cordyceps controlled the minds of its hosts, recent discoveries have challenged this assumption. When examined, infected ants show extensive fungal growth penetrating almost every part of their bodies. Surprisingly, the brain is only slightly affected. This implies that the fungus penetrates deep into the ant's limbs, leaving the brain untouched while hijacking the body. Imagine being fully aware of the fungus slowly infiltrating every tissue of your body, unable to resist its control, and compelled to do its bidding. What if the zombies in The Last of Us were not mindless creatures, but conscious beings aware of their actions as they attacked and bit others? Consider being one of these mushroom-infested zombies trapped by rampant fungal growth in a wall for decades, fully conscious but unable to cry out for help. This horrifying reality is faced by ants and spiders infected by cordyceps every day. However, can cordyceps infect humans? The answer is both no and yes. Zombie fungi are highly specialized organisms, often limited to infecting specific species of ants or insects. This restricted host range has prevented widespread ant apocalypses, which is fortunate considering the crucial role these tiny creatures play in our ecosystem. Moreover, this limitation on infection also hinders significant genetic mutations that could drive evolutionary changes. Nonetheless, every breath we take contains fungal spores. When we venture into nature, we unwittingly inhale spores from various species. Remarkably, our immune system protects us from most infections. Furthermore, the specialization of different species of infectious fungi makes it impossible for them to harm humans. Additionally, humans possess the advantage of higher body temperatures compared to other animals. This elevated temperature makes us less susceptible to infections, including fungi that might attempt to control our minds. Most fungi thrive in warm and humid conditions, which the human body conveniently provides. Some areas, such as the spaces between our toes or under our armpits, demonstrate the fondness of fungi for certain body parts. However, internal growth is more challenging for fungi as they typically cannot survive the temperatures within the human body, which ranges around 98.6 degrees Fahrenheit, 37 degrees Celsius. Fungi wilt in such conditions, akin to the Russian army facing minimal resistance. In The Last of Us, a different form of cordyceps spread throughout the human population via the food supply. This aspect of the show is both the most and least plausible. The interconnected nature of our world today makes a global infection from a single source quite possible. We've witnessed how quickly COVID spread worldwide within weeks of its discovery, and it continues to persist to this day. However, COVID was transmitted through bodily fluids and not via 5G cellular towers, as some conspiracy theories suggest. A simple sneeze or touching one's eyes, nose, or mouth could easily leave infectious residue. Cordyceps, on the other hand, needed to be transmitted through the food supply, surviving on plant matter until it reached a human host. While this may seem far-fetched, a quick look at the labels in your refrigerator will reveal how far your food has traveled before reaching your plate. The United States is the largest food exporter globally, leading in the export of corn, soybeans, and wheat, with annual exports totaling $118.3 billion. Entire countries depend on food exports from major producers like the U.S. China leads in fish exports, Indonesia exports half of the world's palm oil supply, and Thailand exports a third of the global rice supply. Food exports play a significant role in our interconnected world, with Russia even under pressure to allow Ukraine to export its agricultural products. Imagine if a mind-controlling cordyceps fungus infected a soybean farmer's field. With the U.S. exporting more than half of the world's soybeans, it wouldn't take long for the infection to spread globally. However, the most realistic part is not becoming infected through ingestion. The stomach's acidity and low pH levels are generally sufficient to kill most fungi. In fact, humans regularly consume fungi for health purposes, such as through supplements and probiotics. Even Gwyneth Paltrow sells a cordyceps-infused $200 breakfast smoothie on her Goop website. Is Gwyneth Paltrow inadvertently contributing to the end of the world? Is she secretly aligned with cordyceps? Could she be a delusional woman comprised of fungal growths selling overpriced products? The answer to these questions is uncertain, but it is an amusing thought. For now, cordyceps cannot infect humans due to various factors, including our high body temperature. However, evolution is a powerful force, and organisms that can adapt to external pressures survive. As the world warms due to excessive greenhouse gas emissions, organisms must adapt or face extinction. We are already witnessing the adaptation of organisms to rising temperatures, and diseases that were once limited to tropical regions are spreading beyond their historical boundaries. Mosquitoes, for instance, are expanding their ranges and staying active for longer periods, leading to the spread of diseases like malaria, dengue fever, chikungunya, and West Nile virus. What's concerning is that these diseases, along with cordyceps, tend to thrive in environments where human populations have historically been low. This limited their ability to spread, and for cordyceps, it meant less exposure to humans and a lower chance of mutation leading to human infection. However, the sands of time may hold a strain of cordyceps that accidentally acquired the ability to infect humans. Whether this mutation has already occurred or will occur in the future remains uncertain. Given enough time and evolution, nightmarish scenarios become possible. As the world experiences global warming, diseases that were once confined to specific regions are now spreading beyond their usual boundaries. The encroachment of human civilization into untouched wilderness areas only accelerates this process. Notably, fungal diseases like aspergillosis, histoplasma, blastomyces, and coccidiosis are on the rise, and this increase cannot be solely attributed to global warming. Our extensive use of antibiotics inadvertently eliminates competing organisms, providing fungi with an open playing field to thrive in our bodies. However, the transmission of fungal infections from human to human is highly unlikely. This is why cordyceps, in works like The Last of Us, needs to forcibly burst out of its host to disperse its spores, and why mushroom zombies bite people. In theory, Containing a fungal infection should be relatively straightforward. Yet, science seems to be struggling to control the spread of a very real fungus that has begun infecting humans on a significant scale. One such fungus is Candida auris, a relatively new species identified in 2009. Unlike other fungi, C. auris thrives in warm temperatures and has started infecting the bloodstream, leading to severe and potentially life-threatening infections. While its relatives are responsible for mild yeast infections, particularly in hospital settings, C. auris is far more aggressive and easily transmissible between individuals, resulting in widespread outbreaks. Compounding the issue, C. auris has developed resistance to numerous drugs and conventional treatments. Clinicians can only manage the symptoms, leaving the body's immune system to combat the actual infection. Research is underway to develop treatment options. However, fungal infections receive significantly less funding compared to other areas of medical research, with an estimated meager 1.5% of research funds dedicated to this field globally. C. auris seemingly appeared out of nowhere, simultaneously emerging on multiple continents. Scientists suspect that the fungus has always existed alongside us, and rising global temperatures provided the trigger for it to shift towards infecting humans. The fungus has been reported in over 30 countries to date. While it poses no significant threat to healthy individuals, it can be lethal for the elderly or immunocompromised. Unfortunately, the outlook for fungal infections is bleak on two fronts. Firstly, there is little financial incentive for pharmaceutical companies to invest in research and develop treatments. Fungi like C. auris primarily affect a limited population, elderly or immunocompromised individuals, making the potential market for such treatments relatively small. Sadly, without the promise of profitability, saving lives becomes a low priority. Additionally, treating fungal infections presents challenges due to the close genetic relationship between fungi and humans. Drugs effective against fungi can also harm healthy human cells, rendering the same treatment that prevents fungal control a potential threat to the individual's well-being or making them susceptible to other equally dangerous infections. Nature's invisible hand seems poised to create a dire situation if humanity does not happen to get lucky.